All right, hope you guys are well. What is the difference between a well-dressed man on a bicycle and a poorly dressed man on a unicycle? Attire. Okay, let's get to it. I think we're recording, right? Yeah, we're recording. Okay. We're definitely recording, right? Yeah, we are recording. Okay, today we're talking about perimeter area volume. We're starting this new kind of like subtopic within measurement. This is where you've got all your different formulas about perimeter, area, and volume. Okay, now today is just perimeter. Perimeter is the total distance of the boundary. And I'm going to write this here. Essentially, we're finding the outside length, okay, of a closed shape. So the outside length, we're just finding the length of the outside. Okay. Hopefully you remember. So say, for example, let's find the perimeter of these two shapes here. For A, we've got 4 millimeters. And so technically with these little lines here, that means that all four sides are the same, which means in this case, it is a square. So that's 4 millimeters on all four sides. So what is my total perimeter? You're just gonna add them together. You're gonna add all the sides together, or you can notice that, okay, it's 4 millimeters times 4. So that'll be 16 millimeters. Okay. And it's a length. So my units of measurement is also going to be a length. Okay. Now for a question that's a little bit more weird shaped. Okay. For something like this, just start to label what you know. So if that's 2 centimeters, then I also know that's 2 centimeters. And also what I should have done, or with a rectangular-ish shape, if that's 5 centimeters here, we assume that this is 5 centimeters here as well, because they're at the same height. Okay, it's not to scale, but the height will remain the same. And then so if you take a look here, I've accounted for this length. I've accounted for this length. I know that that's 10. I know that this is, again, 5. Now, I'm going to highlight this in red. We don't know what this length, and this length are. Okay, we don't know what they are. We don't have measurements for them, but I know that altogether, those lengths should add up to 10. Okay, so to find the perimeter here, I'll just say something like perimeter equals to, I'm just going to plus things together, 10 plus 10. So that is the bottom 10 and either the broken up top 10, if that makes any sense. And then I've also got the plus 5 for the two left-hand and right-hand sides. And then I've also got the plus 2. That should give you 20, 30, 34, and it's in centimeters. That's your answer. Okay. Now, the main part of this, though, is we are going to get into circles. And if we talk about a circle's perimeter, we call that a circumference. Okay, now we're given two formulas. Actually, we're only really given one formula. Okay, in your reference sheet, the one that you get is this one. And I'll explain the difference between the two. So your main formula that you need to recognize is you've got your circumference is 2 pi r, or pi times diameter. Just a couple of notes here is your diameter. Your radius is always the length from your center to the other side. And so if you think about it, your diameter is always double your radius. Okay, so 2 lots of radiuses is always the same as your diameter. So these formulas are exactly the same. It's like two times of your radius times pi, or we know that 2 times your radius is the same thing as your diameter, pi diameter. Okay, now in your reference sheet, they've given you this formula that says L, and that L kind of stands for, it's an arc length. Okay, so the arc length is this guy here. Okay, and so it's a portion of the circle. Now we know a circle has how many degrees? We know that there's a total of 360. So that's why this here determines the portion of the circle we have. Okay, so that gives you the portion of the circle, and your 2 pi r is just your circumference formula. Okay. So with that in mind, let's actually find find to one decimal place. Normally when you're working with circles, you'll have decimal places. Find the perimeter or circumference, depending on. Okay. For the first one, we're definitely finding circumference because we've got the whole circle. Okay, now I do not need, if I'm just finding perimeter, it's just the outside length. I do not need to count this middle length. Okay, so remember our formula was pi times 2r, or sorry, 2 pi r, or pi times diameter. Now in this particular case, we've been actually given a diameter because the 11 meters is from one side of the circle all the way to the other. So the easiest way for me to do this is my circumference is going to be pi times 11. Put that in your calculator. I believe your pi should be over the times 10 button. It's kind of like on the bottom line of your calculator. And you have to use shift. And you should get, it's roughly 34.557, blah, 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 but to one decimal place. Hopefully you remember how to round. It'll be 0.6. Okay. In this case, will be meters. Now, to find the perimeter, this shape here is definitely perimeter because it is not a circle. Okay, it's part of a circle, but it's not a circle. So we call this a perimeter. Now, to do this, I need to recognize a couple things. I need to recognize it's made up of, I guess, 3 different sides. Okay. Now, I've got the 2 6-centimeter sides. So look, let me just write this in red. Okay, in this particular case, it's just going to be the radius plus the other radius plus the arc length. Okay, so that there is your arc length there. Okay, so given that, that's our perimeter. We know that the radius is 6 centimeters, and I'm not going to draw it. Maybe I will quickly, but like imagine I've drawn a full circle. You can see that pretending that that's the center, this becomes my radius, those edge. Okay, so those are my 6 plus 6. And then to find my actual arc length, I'm going to need theta on 360 times 2 pi r. Okay, because I haven't figured that part out yet. So just kind of simplifying as I go. Now, what particular degrees do I have out of my 360? I can see that it's a quarter. Or in other words, that isn't a 90-degree angle. So I'm talking about a 90 on 360 times 2 times pi times my radius, which in this case was 6. Okay. Now, for those of you guys that were pretty sharp, you recognize this was a quarter of a circle. And so that there could be how you calculate it. At this point, you could put it straight into your calculator. Plus. And you should get the answer to one decimal place, 21.424, blah, blah, blah. So to one decimal place would just be 21.4, and this would be centimeters. Okay. Hopefully that makes sense. All the best, and I'll catch you guys in the next one. See you later.